But you will put the longer years in such a way that the average year is a solar year. What are examples? Okay, let me tell you that almost all calendars of the world fall in this category. I mean, if somebody just asks you a question about some calendar in some part of the world you know nothing about, and ask you to guess whether it's a solar or a lunar or a lunisolar calendar, always guess lunisolar, because you'll be right maybe 99% of the time. Calendars of northern and western India are of this sort: the Chinese calendar, the Hebrew calendar, and many others. Okay, I cannot possibly give all the names or even survey some of them. Okay, so what we will do in the rest of the talk is that we'll take some sample calendars from each category and we'll discuss how those calendars function. From that, we'll have an idea of the calendrical science and the intercalations that calendars have to make. So, you see that this is a next chapter. The background has changed. So, we'll talk about the Roman calendar first. It is a solar calendar. At least in its present form, it's a solar calendar. It was not always so, and we will see that it was not always so. It was actually borrowed from Egypt. The Egyptians were sun worshippers, so naturally they had a calendar based on the movements of the sun. And when Julius Caesar invaded Egypt, actually this is a funny way of the way we learn history. That, I mean, if you had asked me before I got into this study of calendars, that name one important person that Caesar met when he invaded Egypt, I would have said Cleopatra. And I can bet that most people will give the same answer. But actually Caesar's encounter with Cleopatra meant nothing for the rest of history. The important thing that happened is that Caesar met an astronomer called Sosigenes, who was a calendar expert. And Caesar brought him to Rome when he came back. And we'll see what happens from that. Now, some other things about the Roman calendar that we should know from the beginning is that this is the one which evolved to become the international calendar, which is the one according to which is 24th of May today. And this is also the calendar which is commonly called the English calendar in India. This is an abysmally bad name. I mean, I would request you, if you do not get anything out of this talk, please at least remember this one thing. This is not English calendar. Never call it English calendar. And I will explain to you why it's a bad name. So, how was the calendar? Okay, let's start from before around 700 or 750 BC. Around that time, there was a ruler in Rome whose name was Numa Pompilius. Numa Pompilius. Before him, how was the Roman calendar? The year started with a month called Martius. You will recognize it by the English name March. It had 31 days. And then Aprilis, 30. Maius, Junius. These four are names of different gods and goddesses. Then there was Quintilis. Quinque means 5. So this was the 5th month. Then Sextilis. Sex, don't confuse it with the English word. Sex means 6 in Latin. So this was the 6th month. And then September, Septem, Saptam. Remember the Sanskrit word, Saptam, 7th month. October, Ashtam. November, Navam. December, which was in Latin, it was pronounced as December, but December is Dasham. So these were the 7th, 8th, 9th, and 10th months. And this is all because the year started from March. Now, you must have noticed that I have kept a little blank space before the March. Why? You know why. I will fill it up. But before Numa, there was nothing which existed in those blank spaces. What was done is the following, that these 31 and 30 months added to 304 days. And here was the rule of intercalation for that calendar. After the 304 days, the calendar was stopped. And it was stopped for what we would now call about 60 days. And then when spring comes, there will be an announcement, okay, the new year will start tomorrow or 2 days from now or whatever. Okay. So during January and February, I mean what we now call January and February, there were no months. People didn't count them. They were winter months. Why do you need to count days in those months? Now, this might seem funny, but actually this is roughly the way that as a child, I grew up with the calendar. I mean, when I grew up, in the beginning of December, the school exams will be over. And then for all practical purposes, we would not even look at the calendar. We would not know which day of the week, which day of the month, and so on. We will just play from morning to noon, come back home, have lunch, then go play. In the afternoon, come back, have lunch, then go play. So this was our routine until about a month later, when we were happily sleeping in the morning, my mother would come and push me and said, hey, the new year starts, you have to go to school now. So the new year would start. This is exactly the way the Romans treated the year. You don't need to count the days when there is no need for it. Now, this changed with Numa. That is why I said this was before Numa. This changed in Numa's time. So Numa made the following changes, and these changes were made around 700 BC. Okay, the first big change you see that he introduced 2 months here, Januarius and Februarius. Okay, and what were the days of the months? Okay, let's still start from March because they still have the year starting in March. 31, 29, 31, 29, 31, 29, 29, 31, 29, 29, 29, 28. Okay, and this, the total would be 355. So you see, you remember the number 355 or 354. These were like 12 synodic months, lunar months. Okay, so at this point, the Romans certainly followed a lunar calendar. They had a lunar year. But they would also like to start the March or the Martius at the beginning of spring. So what they do is that this 10 days or 11 days shortfall, so they would introduce 22 or 23 days after every other year, so that the March starts in springtime. Okay. And another interesting thing that you should notice in this calendar is that there are mostly 31s and 29s in the number of days in the month. There is no 30. Why is that? Oh, that's because around these times the Romans had this superstition that all even numbers are bad. Even is evil. Okay, so you cannot have even number of days in a month, because that would mean that it's a bad month. So that's why all the 31 and 29s. But then you will ask, okay, but then why in February there was 28? Oh, because in February, if you also have an odd number of days, then the total will become even. That would mean disaster for the whole year. So February, being the end of the year, would somehow, okay, it's a bad month anyway, it's a winter month. So it is kept for at 28 days, so as to keep the total number 355 in a year. Now, the next big change came at the time of Julius. As I had already pointed out, he came back with Sosigenes from Egypt, and with the help of Sosigenes, he created a new calendar. He said that first of all those things about superstitions about even numbers were probably gone by then. So he said we don't have to worry about those things. But the year should be a solar year, and it should have 365 days. So if you again start from March, it's 31, 30, 31, 30. All along it's just alternately 31 and 30, except February, which is 29, just to make the total equal to 365. So you see, this is a very, what should I say, symmetric calendar. 31, 30, 31, 30 all along. February has 29, okay, but that's the end of the year, so there you can expect some irregularity. So if you do this for all years, then the total number of days will be 365. But the Egyptians also knew the year was not really 365 days. They thought that the year is 365 and a quarter of a day. So 365 plus 1/4. So you have to add one extra day in February every fourth year. And in those years, the leap years, so to say, February would be 30 days, and it will be completely symmetric throughout the year with 31s and 30s. But there is a problem. The problem is that when Julius explained these instructions, he used some words which I really cannot reproduce because I don't know Latin. But he said something like, after 3 years, you add one extra day to February. Now, this after 3 years kind of thing can be can be problematic, because, like, suppose I say that, uh, you know, I went to Mohali 10 years ago. What would you conclude? Did I go when the time I went to Mohali and from now is the 10 years, or was the 10 years intermediate and this is the 11th year? So it's this kind of problem. And the Romans actually misunderstood it. And I'll come to that. What they did with the misunderstanding. But before that, I should say one thing, that Julius made all these changes and he was very happy. And he thought that the calendar should have a permanent signature, a permanent mark of his name. So this first few months, which are named after the gods and goddesses, he did not touch. But the fifth month, which was called Quintilis, he renamed it and called it Julius. That's the July, now. So then this calendar, the Romans started using this calendar, but as I said, they started putting this extra day at the wrong time. They started putting it every third year. And this was noticed at the time of Augustus, 38 years later. This is 46 BC and this is 8 BC. 38 years later. See, if they had put the leap years correctly, in that 38 years they should have had 9 leap years. But because they were putting it after 3 years, or every third year really, they had already 12 leap years. So they had overcounted the days. And this was noticed at the time of Augustus. So Augustus said that, look, the real rule for putting this extra day in February should be every 4th year. Once it is done, you have a hiatus of 3 years, and then after that, in the 4th year, again you add an extra day in February. Okay, that's certainly a good thing, but the rest of the thing that he did was not very good, I must say. See, people have so much ego that after making this change, Augustus thought that, oh, Julius has a month in his name, so why shouldn't I have a month in my name? And the 5th month, the Quintilis, Julius already named after him, so Augustus took the next month, Sextilis, and he said that this month should be known as Augustus. And then he did something which is even worse. He said, oh, wait, Julius's month has 31 days. So why should my month have 30 days? He said, no, my month will also have 31 days. And to account for this problem, he had to change September, October, etc., etc. So he had to change everything, and finally he had to take out 1 day from February, and February became 28. So February, which was 29 in Julius's, after Julius's correction, and was actually 30 in a leap year, became 28 or 29 after Augustus. After Augustus, the person who became the emperor of Rome was Tiberius. Tiberius looked at these things and he said, I mean, what will happen when Rome will have its 13th emperor? If I have to have a month for each emperor, we will not be able to accommodate more than 12 for sure. So he made a rule that nobody should be able to change the calendar from now. I have to admit that I find it surprising. I mean, I would have expected that the Tiberius would first have a month in his name and then make the rule. But he must have been an amazing person. He didn't really want anything for him. He just said, okay, I don't want anything in my name. I don't want anything in anybody else's name. Just let the calendar be. And that's how it has been until now, almost. Almost. Because there have been changes, and I'll come to that now. So, the big change came in the form of Gregorian reform. Let's see why the change was necessary. See, the average year in Julian calendar was 365 plus 1/4 days. So that's 365.2500. But you remember that the astronomical year, which I quoted a few slides earlier, is 365.2422 days. The discrepancy is 0.0078 days. Now you may ask, is that serious? That's like 11 minutes and 14 seconds. Who cares about 11 minutes in a year? Well, you'll have to care, because the calendar goes on for hundreds and thousands of years. So after 1,000 years, the discrepancy would become 1,000 times this, which is 7.8 days. That's roughly 8 days. That's not trivial. So something has to be done. Actually, that something needs to be done was noticed as early as 325 AD. There's a convention of Christian church in somewhere in Western Asia, Nicaea, and it was noticed there that the vernal equinox comes not when it should have come. But then they said that, okay, let's say that the vernal equinox date is 21st of March. But they didn't really, maybe they didn't understand or they didn't care about why it shifted from 21st of March. So they didn't do anything about correcting the calendar, so to say. So this discrepancy started growing again after 325 AD. And it was noticed by scientists in 1471. The scientists in Rome appealed to the Pope, Pope Sixtus IV. Why to the Pope? Because it was a Roman calendar, and at the time it was sort of decided that whoever will be the greatest authority in Rome, he should have the power for changing a calendar if change has to be made. Now, at the time when this was said, the most important person in Rome was the emperor, but the Roman emperor has vanished by 1471, and the most important person in Rome in the Christian Pope. So the Pope was Sixtus IV, and the scientist appealed to him, said that some calendar reform is necessary. Now, as we know, the church is usually very prompt in considering these sort of appeals. So they took a decision within 111 years, and the Pope at that time was Pope Gregory the 13th. He actually approved the reform. And that is why I will describe what the reform is, but because Pope Gregory approved it, it is called the Gregorian reform. So here is a lesson for you, that if somebody tells you that something needs to be done, do not wait 111 years for doing it. See, if Pope Sixtus had taken the decision immediately or within a year or two, we would have called it Sixtus' reform. But Sixtus is unknown, and everybody knows Gregory the 13th because he approved the reform in 1582. So what did he approve? Okay, first of all, note that 1257 years. See, Nicaea Convention was 325, and this is 1582. So 1257 years had passed since the Nicaea Convention. So the discrepancy had accumulated. 0.0078 times 1257, that's 9.8 days, roughly 10 days. So in 1582, Pope said that the 4th of October would be followed by the 15th of October. Take out 10 days. Bring things to where it should have been. Okay. So this is the calendar of Italy of 1582 October. 1, 2, 3, 4, 15. Nobody should learn the numbers by this calendar, by this month. This is from the website called timeanddate.com, and there are very beautiful things on that website. I recommend that if you're interested, spend some time. I have spent a huge amount of time there, but it didn't come when I wrote the book. Actually, it came much later. Anyway, so that was Gregory's correction, but that's not all, because you have to prevent this discrepancy accumulation for the future. So a new rule had to be there to prevent future problem. And the rule was like this, that the years divisible by 100, which according to Julius's rule would have been leap years because they are obviously divisible by 4. But now the new rule is that if the years is divisible by 100, they will also have to be divisible by 400 in order to be a leap year. So for example, 1700, 1800, 1900 should have been leap year according to Julian calendar, but not leap year in Gregorian calendar. But 2000 was a leap year. So you see, it was very clever, because after 1582, the first 100-year centenary year comes is 1600. There was no problem with 1600. It's the same in Julian and Gregorian. So people get time to get adjusted to the new system. And the first difference really does not come until 1700, which was 118 years later. And everybody should expect that by that time people should get accustomed to it. So now the average length of year after this reform was 365, plus within a 400-year interval, Julius had 100 leap years, but 3 of them would not be leap year according to the Gregorian reform, so 97 leap years. So that is 365.2425 days. That is still not perfect, because the real thing is 365.2422 days. So there is still a discrepancy of 0.0003 days per year, which means that in order for a 1 day discrepancy to accumulate, it will need more than 3,000 years. But still, it will accumulate. So is there a prescription to avoid this? There have been prescriptions. I will not go into them. I will only tell you the prescriptions which I think was accepted finally. And this solution is use the earth in such a way that it doesn't last for 3,000 years. Turn on your AC for the whole amount of day and night. Use car wherever you want to go to. So just pollute the air and pollute the air, pollute the river, just destroy the mountains. The earth will not continue to live for 3,000 years, so we will not have to face this problem. That, I must have to say, is a brilliant solution. Okay, but at this point, I will say that how Gregorian calendar was adopted at different in different countries. 1582, the Catholic countries, Italy, France, Spain, Portugal, they immediately took it. Pope, whatever Pope has ordered, they will take it. And then the next year, Switzerland, Netherlands. Year after that, Germany was not a country at that time. So there was a Catholic part of Germany and there was a Protestant part of Germany. So the Catholic Germany actually adopted the Gregorian calendar. But the Protestant Germany said that, oh, no, it is something the Catholics are trying to impose on us. We will not accept it. But finally, more than 100 years later, they agreed that, okay, maybe that part, the Catholics were right. So they changed the calendar. But remember, the 1700 was the year where things started getting different again. So the discrepancy, already 10 days discrepancy, they did not correct. And now one more day, 11 days. So this is how the German calendar looked from January to March. January, nothing important. February, 1 to 18. But then 19 to 29, it would have been 29 if Julian calendar was followed. 19 to 29 was eliminated. After 18th, the next day was 1st of March. England. Now I should pause a little bit. Remember I said that this Roman calendar, the Gregorian calendar, in India, it's often called the English calendar. Have you ever noticed the name of England or about English in anything about the history that I am telling you? The answer is no. The England did nothing for this calendar. Nothing. Not only that, when in 1582 this correction was mentioned, for 170 years, they did not even pay attention to the calendars, to the new calendar, the Gregorian calendar. So, I mean, if you call that the English calendar, that I must say from my Bengali point of view, that it's like calling Rasgulla a Gujarati sweet because maybe some store in Gujarat sells Rasgulla. Okay. So England finally woke up in 1752. The discrepancy was 11 days after 1700. So September 2nd was followed by September 14th. And it created some problems. For example, Newton's birthday. I read in some books that Newton's birthday was 25th of December, 1642. And in some other books I read it is 5th of January, 1643. Now, when I was very young, a little child, I thought that such a big person, such an important person, certainly can be allowed to have two birthdays. But then I realized that that doesn't happen, even for the most important person. The birthday is the same. The birthday was 25th of December with the wrong calendar. But if England had taken the Gregorian correction timely, then it would have been the 5th of January of 1643. And I am not going through many other countries. Russia, after the Bolshevik Revolution, the revolution was in 1917, and in 1918, the makers of the revolution decided that we should change the calendars. The discrepancy was 13 days by then. So 31st of January was followed by the 14th of February. 31st January, Wednesday. Next day was 14th February, Thursday. And again, this created problems like the Russian Revolution Day. Was it the 25th of October because it's the October Revolution? Or was it the 7th of November because it is November Revolution? The solution is the same. It was October with the wrong calendar, November if they had corrected the calendar. Now with this, I will end my discussion on the Roman calendar and its modifications. I will next go to an Islamic calendar. And as I said, in the modern world, there is only one lunar calendar. That's the Islamic calendar. So how does it go? Okay, the average length of the year is just 12 months, synodic months, 29.5306 days. That's 354.3672 days. So each individual year is either 354 or sometimes 355 days. As you see, this creates a difference with the solar year of 11 days. So this calendar sort of moves with respect to the seasonal cycle by about 11 days each year. Let's look at the date for Eid al-Fitr as it comes on the Gregorian calendar. In the Islamic calendar, the Hijri calendar, it's the end of the month of Ramadan. Ramadan in Arabic or Ramzan in Persian. So how does it figure in the Gregorian calendar? Okay, I'm giving some old years because of a reason. I will explain it to now. See, in 1998, it was Eid al-Fitr was 30th of January. Next year, see, it has moved back 10 days, 10 or 11 days it will move because 354 or 355 moved back by 10 days, 20th of January. Moved again 11 days, 9th of January. But now, if you go from 9th of January 2000 and count 354 days, you don't go to 2001. You are still in 2000. So in the Gregorian 2000, there were two Eid al-Fitrs, 9th January and 354 days later, which was 28th of December. And then it moved again 11 days, 17th of December, another 11 days, 6th of December, and so on and so forth. That's how it goes. In roughly about 33 years, which is 365 divided by this 11, roughly in about 33 years, it will again come back to the end of January. That's how it is. So the fact that the Hijri calendar started in 622 AD, if you ask which Hijri year it is now, it will not be 2025 minus 622, because the calendar length is different. Okay? This is how the Islamic calendar functions. And now let me give you example of a lunisolar calendar. And of course, the easiest example that I can give you is the calendars which are obeyed in northern and western parts of India. So let's say the Gregorian dates of the Dasera in this calendar. Okay. Here again, here I am going down in this chart. So let's say in 1997, it was 11th of October. 10 days, 1st of October, 1998. But then it did not go another 10 or 11 days back, because that would be going a little bit too far. So what you do is that you intercalate 1 month between the Daseras, or I'm more accustomed to saying Dashami, of 1998 and 1991. So it was supposed to move up by 11 days, but you have put in a month which was like 29 days. So that means it will move down by 29 minus 11, which is 18 days. And that is exactly what it has done. From 1st of October, it has gone to 19th of October. Again, come back 11 days. But then again, another extra month has been intercalated. So another 18 days add to it, and it goes on like this. So you see, always you are intercalating months such that this day arrives around the same time in your seasonal cycle. You see here, its earliest one is 28th of September, and the latest one is 26th of October. Okay, so within this time, Dashera or Vijaya Dashami would appear always, and you adjust the calendar, introduce a month before, such that this happens. How is this month introduced? I'll come back. First of all, let's see how often you should introduce this. So I'll say, okay, roughly once in 3 years, because it's 11 days and 1 month is roughly 30 days. 30 divided by 11 is roughly 3. Roughly 3 is yes, but that's very rough. Recall that 1 year is 12.3683 months. So you have to account for this fractional part, 3683. Once in 3 years would be 3333. That's really not a very good approximation of this fraction. Fortunately, there is an approximation which, without going to very large numbers, which is 7 over 19. 7 over 19 is 3684, which is okay. So if you intercalate 7 months every 19 years, then you are fine. Now the question is how and when these months would be added. Okay, this varies from one lunisolar calendar to another, and I will come back to the details. Let's see one example, which is how it's done in the Hebrew calendar, the Jewish religious calendar. Okay, in 1 year, the extra accumulated month is 3.3683. We do nothing. In 2 years, it's double that, do nothing. In 3 years, it has, the extra accumulated month is now more than 1. So you add 1 month so that the discrepancy reduces. You have reduces 1 from this 1.1048, so we are left with 0.1048. and then you start accumulating again until it again goes above 2. So then you put another month and so on. So this way, after the 10th, 11th, and 19th also you put 1 month, and then your discrepancy is 0.003. That's very small, and we are not dealing with that here. But this is how it's done. So basically the idea is you just keep track of how much discrepancy has been accumulated. Whenever it crosses a whole number or comes very close to a whole number like here, then put 1 extra month. This is their strategy, the Jewish calendar strategy. That is not the strategy of the Indian calendars, and I will come to that. But before that, I'll have to talk about the Bengali calendars. You probably anticipated it, but I'm saying it not just because I'm a Bengali. It has some features which are very unique and which are not always nice features. So I'm not talking about Bengali calendars to tell you, oh, how great the Bengali calendar is. It's not great. Okay, let's see what it is. First of all, it's a solar calendar, and it follows the calculations of Surya Siddhanta, which was an astronomical text written in 6th century AD. Remember this 6th century, it is important. So 1 year in Surya Siddhanta was 365.2587 days. That's a discrepancy of 0.0166 days per year. Okay, what does that do? Okay, you see what does that do. The Bengali New Year Day, the intended date was a vernal equinox, which was 21st of March. Because that's a good day when to start a new calendar, right? I mean, that's an astronomical phenomenon and it's common to the whole earth, so you can adjust or you can calibrate things by that. So 21st of March, but during 1400 or so years that has elapsed since this 6th century AD, the accumulated number of days is like 23. So the Bengali New Year's Day now falls on the 15th of April. But there may be 14 or 15 depending on where is leap year and so on, but around that time, 15th of April. Rabindranath Tagore's birthday. Rabindranath Tagore was born on the 6th of May. It's not something that he remembered, his parents remembered, so it was written in his autobiography that this was his birthday, as he was told by his parents. But since his birth, about 165 years have passed, and this discrepancy has accumulated to 2.7 days. So nowadays the birthday more typically falls on the 9th of May. Sometimes 8th because of this extra day, 29th of February sometimes, but usually it's on 9th of May. So this is what the calendar does. I mean, it is moving away from the real count. Why is the discrepancy? Why was this 0.0166 days per year? Okay, first of all, the calculations were not very refined in 6th century, we have to admit that. So there must have been some discrepancy which came because of that. But that is not the main part. The main part is that the precision of equinoxes was not taken into account in this Surya Siddhanta. So now I have to describe what is the precision of equinoxes. What are the equinoxes? Okay, here I have shown the Earth in 4 different positions in its orbit around the sun. The sun is this little dot in the middle, as I told you, obviously not to the scale, you cannot do it. So when the earth is at A, you see that the axis is tilted. So when the earth is at A, the north pole is nearer to the sun than the south pole. The northern hemisphere is nearer than the southern hemisphere. So it is summer in the northern hemisphere and winter in the southern hemisphere. And the discrepancy of daytime and nighttime is the maximum on the 21st of June. Then Earth moves, and in autumn there is an equinox. Equinox means that if you draw the line from the sun to the earth, this axis will be at right angles to it. In other words, the north pole and the south pole will be equidistant from the sun, and that's 21 September, 21st September. Winter solstice is when the northern hemisphere is farther from the sun than the southern hemisphere. So it's summer in the southern hemisphere and winter in the northern, and the solstice is on the 21st of December, and then the vernal equinox is 21st of March. This is the 21st of March, which I talked about in this previous slide, which was the intended date for the beginning of year in a solar calendar. It's a good date to start a solar calendar year. Now, the problem is that there is this axis. The axis is not really perpendicular to the Earth-Sun distance line, the imaginary line that connects the Earth from the Sun. But there is also the fact that the axis is not pointing in the same direction. It wobbles. It's like when you have a top and the top is spinning, the axis of the top wobbles like this. It's like that. So we have 3 different motions of the Earth. We know about the diurnal and the annual motion. The diurnal is what gives the day motion around the Earth's own axis, and annual is a motion around the sun. But there is also a third motion, which is the precession, and this is the axis wobble. And this wobble takes about 25,800 years to complete. Now, this is something that the Surya Siddhanta people either did not know or did not care about. And if you take this into account, then let's ask this. Which one would you care for? Would you care for just one complete rotation 360 degrees, or will you care for one period when the north and the south pole are equidistant to the next time when they're equidistant? Okay, it's obviously the second one, because then that's the one which defines the seasons, and that is different because of this wobble. Because of this wobble, this period of going around the sun is a little less than the 360 degrees rotation around the sun. Remember what I told you about the rotation of the moon. The synodic month and the sidereal months are not the same. Here also there are different definitions of the year, and this is the one we would care for more, because this is the one which governs the seasons. So that's 3422. If you disregard this thing, so if you really consider the 360 degrees rotation, then it should be 0.2564. And this is the thing that Surya Siddhanta wanted to measure, but they made a little error, and that is excusable. They said it's 365.252 2586. So the Bengali calendar is really following this length of the year where the wobble is ignored. So they are following a wrong length of the year, so to say. And what is even worse is that there are really two different schools of Bengali calendar. One of them follows really what was said in Surya Siddhanta, and one of them takes the wobble ignored time period in its modern version. So there are two different calendrical calculations, and they're both following the wrong solar year. And the Bengali Hindu festivals are determined not by this Bengali calendar, by the way. They are determined by the lunisolar Indian calendars, the calendars of the northern and western India. That is why the festivals do not come on a fixed date on the Bengali calendar, just like they do not come on the fixed date on a Gregorian calendar. So now comes the last question, maybe not the last, but the question about how Indian lunisolar calendars intercalate. Okay, we have described the lunar month before, and the length is 29.5306. Now consider something called the solar month. Solar month, okay, if you take the 360-degree rotation divided by 12, so that will be 30. So it's 30-degree rotations. 30-degree movement about the sun on the zodiac, which means 30-degree movement of the earth around the sun. So the interesting thing is, in Bengali calendar, the months are really determined by this 30-degree movements of the sun. So the months when the sun is closest, when the earth is closest to the sun, tend to be shorter, and the months when the earth is farthest from the sun are longer, sometimes 32. I have even seen 33 days months. Okay, now so the average solar month is 30.43, about 30 and a half days. Of course, some months are longer, some are shorter. But then it is possible really that a lunar month will start within a solar month and will finish within that same solar month. So it will completely reside within one single solar month. This kind of month is called a molomas. In Bengali we call it a molomas. In Hindi I think adhik mas is the more preferred word, but it means the same thing. Adhik mas means it's the extra month, which, so if you have a lunar month which completely stays within a solar month, then you don't give it a new name. So if it comes after, let's say, Shravan, you call it Adhik Shravan. Or if it comes after Bhadra, you call it Adhik Bhadra. You don't call it Ashwin. Okay? This is the intercalated month in Indian lunisolar calendars. And on these months, you are not supposed to do many things because of there's some superstition around this month. So that is how it is determined when you will have this superstitious month. Okay, now the last topic. Everything I have discussed so far is astronomical things. There are some non-astronomical elements in the calendars, which I will go through it very briefly. As you see, this is the slide 20 of 22. So it's a very small portion of my talk, because this is, in my opinion, not the interesting part of the calendars. The first thing is era. Like this is 2025 in the Christian era. Christian means it has something to do with the birth of Christ. So an era starts with an important event in human life. It has nothing to do with astronomy. Maybe somebody's birth, maybe somebody's ascension to the throne, this kind of thing. Okay, And I have not discussed it at all, and I will not discuss it more. The other thing is the week. This is the cycle which was determined mainly by market days. You see, a long time ago, people did not have refrigerators. So they'll have to go to the market and buy things and store it at home. Now, if you have market once in a month, then you buy something from the market and it will just rot in your house. So you'll have market days more often than a month. And the cycle, different civilizations chose different cycles. Some chose 6, some 7, 8, 9. In Christian countries, a 7-day cycle was decided upon by the church, and that probably had to do with something also with the fable of Genesis in the Bible. But the 7 days were named after what were called the 7 planets. This is not planet in the modern sense of the term. This is planets as they were called before astronomy was developed to the modern extent. These are the things that people saw them moving in the background of stars. So of course the sun moves. So this is the Solis, the sun, moon. These are the Latin names. Lunae, Luna is the lunar, that's the moon. Mars, Mercury, Jupiter, and this is the Venus and the Saturn. So this is how the days were named. But that brings a new question. Why is this order? What determines the order? And that, okay, probably the best answer is this. Consider these 7 things, which now I have given the English names, and consider their sidereal periods. That is the cycle in the sky in which they move in the background of stars. And now I have arranged them from the smallest to the largest. The moon has a cycle of 27.3 days. This is the sidereal month, which I have talked about in the beginning. And then the Mercury, Venus, Sun, etc., etc., etc. The Saturn has the longest. It has about 29.5 years. So now what happened is that there are also 24 hours in a day. How it was decided upon is a different story, and I will not go into that. But apparently the hours of the day were also named after these planets, the wanderers. How? Okay, this is how. So suppose you take this table and just run it backwards. Saturn, Jupiter, Mars, Sun, Venus, Mercury, Moon. Now, you start your week on Saturday, which is Saturn's day. And the first hour belongs to Saturn, the second to Jupiter, third to Mars, and it goes like this until the 8th hour is again Saturn, 15th hour is again Saturn, 22nd is again Saturn, 23rd is Jupiter, 24th is Mars. That's the end of the day. The new day starts. Now, after the Mars, there is the Sun. So it's a Sunday. Again, 1, 2, 3, 4, you go on until you reach Mercury on the 24th hour. So the next day is after Mercury, there is the Moon. So the next day is, the first hour belongs to the Moon. So it's the Moon's day or Monday. So the day of the week gets the name from the planet that occupies its first hour. So in this sense, it is also related to the astronomy things. It's not completely non-astronomical, but it has some non-astronomical elements, like why are there 24 hours in a day? And I'm not going into that. As I said, I'm not going into anything else really. Now this is 21 of 22. What is the 22? Oh, somehow it was counting wrong. I had really 21 slides. So this is the end of the talk. Thank you very much for your patience, and I'm sorry if I have gone with, I mean, if I have overdone with the time.
No, no, not at all. Thanks a lot, Palash. This was absolutely amazing. Okay, we have time for some questions. Uh, I will read out some comments from Shailaja, who unfortunately had to leave the meeting a few minutes ago.
Hmm.
And before that, maybe I can use my privilege as host to mention something. In a talk which I attended long ago by K.D. Abhyankar, he mentioned that Aryabhatta was probably misled about precession because in between Jain astronomers had shifted the start of the year from vernal equinox to the month of Shravan. And therefore, looking at the records, he felt that maybe it is a periodic correction and not to be taken into account. However, I see this comment from Shailaja which says that Surya Siddhant does talk about precession. It even talks about how to take this into account, except that it needs to be taken into account and people never did. So I was wondering if you are aware of the situation.
I don't know. I cannot comment. I, I mean, when I first wrote my book, I I read the Surya Siddhanta. I mean, Bengali translation of it. But I don't remember seeing it. But maybe I have missed, or maybe I have forgotten. It's possible. But whatever it is, the Bengali calendar at least does not take it into account. That much is true.
Right. And okay.
Not only Bengali calendar, I think almost no calendar takes into account, as far as I understand, which are
Yeah,
calculated according to the either Surya Siddhanta rule or, I mean, some alteration.
yeah. That was my understanding also. Yeah.
Right. So lots of questions in chat. Uh,
Oh, I can open the chat also here, right?
I think so, yes.
Yeah, yeah, yeah. Okay, yeah, I just did. Yeah.
Uh,
Okay. Let me take this one. On to the Mahakumbh dates are so off, right?
that's actually a series of conversations going on. Someone asked why Mahakumbh comes every 12 years, and
Uh,
Alok mentioned that Mahakumbh is Sun and Jupiter in Taurus,
yeah.
and as that happens roughly every 12 years.
Okay.
But yeah, so she's saying that Mahakumbh dates are off because Jupiter doesn't have an exact 12-year orbit.
Yeah.
Okay, there is a hand up. Let me just check. See. If anyone wants to ask a question, maybe you can type in chat or yeah. Does anyone want to ask a question? Please unmute yourself and ask.
Hi, this is Jwalant here. Sir, one question. Uh, with this latest calendars that we have, do we do justice to the real seasons, or what is the nearest calendar if you wanted uh, to look at the seasons as the primary uh, center of view?
By the latest calendar, do you mean the Gregorian calendar?
Right. Yes. Yes.
Yes, Gregorian calendar, as I said, the discrepancy is about 0.0003 days per year. So it was already adjusted in 1582, and it will take um, more than 3,000 years to accumulate 1 day of discrepancy. Okay.
Right, sir. But I do also hear that the seasons have a lot of variations based on the moon and other geographical the movements. So, does it take care of the moons? Because only the lunar calendar would kind of look at the moon's impact on the seasons, right?
I don't think the moon has a major role to play for the seasons. The seasons are mainly determined by the sun.
Thank you, sir.
Jinash, you can ask a question.
Sir, in the slide when we were talking about adding 7 months in a total of 19 years, over there we had a end discrepancy of about 0.03 days. So
Zero
I did
zero.
not understand. So I did not understand why we were ignoring that.
Oh, no, 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 no. I am ignoring it for this talk. I mean, I would not go to the things that they make for that they do to adjust that. Okay, I left it there. So they have to make. I mean, they have to make more adjustments to get that right. Yeah, but
Thank you,
seven
sir.
seven over 19 is just a rule of the thumb thing that you can do easily and count easily and think about easily. The cycles, the bigger cycles are probably 235-month cycle and so on and so forth. So those are more difficult. I did not just go through those calculations. That's all I wanted to say.
So it's a trade-off between convenience and accuracy.
You have to be accurate to some extent.
Okay.
By to some
Thank you.
extent, I mean that you shouldn't lose too many days in your calendar, lose or gain too many days in your calendar, right? But
Yes,
also
sir.
you have to keep everything in terms of integers. And integers means even when you try to approximate functions, you, I mean, let's say that between the Julian year and the real year, there was a discrepancy of 0.0078 years, right? So I could have said, okay, so make 78 longer days in 10,000 years and that will do it. But keeping track of 10,000 years is not something that happens in a human lifetime, and so a human, will not be able to appreciate that thing. So you have to bring it to fractions whose numerator and denominator are not very large, and then make small adjustments to that, whatever happens. So that's why the 7 over 19 is good enough that you can think about 19 years easily. But if you have to think about 235 years, then it will be difficult. So for that,
Okay.
it will be different.
There is a
Thank you so much, sir.
question and comment in chat. It says that the problem you describe with Bengali calendar is same with the Punjabi calendar also. Wanted to ask why the names of months in these purely solar calendars are derived from those of the lunisolar calendars like Chaitra, Vesak, and so on.
Yeah, I should have mentioned that this has caused probably more confusion because the names of the months are same. Uh, I really don't know why they are the same. Probably because of some history, but this is a part of history that I don't really know. Okay, but uh, I can imagine that no, let me put it this way. Okay, there is the solar calendar and there are the lunisolar calendars, right? And there was a time when the names of the months were different actually. So there were like Madhu and Madhav, Tapas and Tapasya. I forgot for which one, but it's in my book, but I forgot. So there were different names, but those different names did not stick, and I don't know for what reason. So I cannot answer this question. If somebody knows, I'll be happy to learn the answer.
Yeah, so any other questions? We can maybe take a couple of more questions before we close.
Yes, sir.
Yes, I am. Go on.
Sir, I wanted to ask, there are very few nuances that we haven't taken into account, like nutation and the fact that Earth's rotation is slowing down. Will these effects cause any problem within the next, like you said, 3,000 years? तो एक दिन का era rise आएगा, but before that.
Okay, it will cause a problem, but that time scale is longer.
Longer than 3,000 years.
I'm not sure whether it's longer than 3,000 years, but it's longer than 1,000 years. That much I remember. Okay, so yeah, I mean it is long enough that between the Gregorian reform and now, nothing has changed.
Sushant had a question.
Sir, I had a question that you mentioned that due to precession of equinoxes, 20 minutes difference is being created. So I'm not able to understand why that 20 minutes difference is being created.
Okay, there are there are two things. There are two time periods that we are comparing. One time period is that the Earth goes around the Sun by 360 degrees. Okay, this is number one. Number two is one spring to another spring, and by spring I define when the North Pole and the South Pole are equidistant from the Sun, and it's after the winter before the summer. Okay, North Pole and the South Pole become equidistant from the Sun at two times within a single orbit. Okay, one is the spring and one is the autumn. So after the winter and before the summer, that's the spring equinox. So spring equinox to spring equinox is one time, and 360 degrees going around is another time. The question is, are these two times the same? Right? Now, you can probably very easily do this experiment at home. I don't know how it will show in the on your screen, but this is the Earth's orbit, let's say, okay, and it's going like this. Okay, but this is not all it does. It is also doing something like this. I'm exaggerating, of course. Okay, it's also doing something like this. So if it is doing this, then the two time periods will not be the same. Okay, I mean, the question is about the axis. The axis is not a fixed direction, so the axis moves a little bit, and remember that it's a very small thing. One wobbling takes 25,800 years. Okay, so it's a small thing, but that small thing already affects when the North and the South Pole becomes equidistant from the Sun. Right? So that's why the 360 degree rotation is not the same as this thing.
So what we refer to as an year is the time period it takes for the North Pole and South Pole to be equidistant from Sun.
There are different definitions of the year, just like there are different definitions of the month, and the question is which definition is more important for us or more convenient for us. Okay, for example, let's say for the month, I have already given you two definitions, right? One is you look at the stars, which star the moon is near, and see when again it comes back near the same star. That's the sidereal month. And another is the full moon to full moon. Now, if you think of these two definitions and you think about a time when people did not have telescopes, it is very easy to understand that the second definition is much more easier to understand. It's much easier to see the full moon than to see the stars, because you will not be able to see the stars very close to the moon anyway because of the moon's brightness. So, so it is convenient to use the synodic month, the full moon to full moon definition of the month. Okay, for the year, which one is more convenient or more necessary for us? It depends on what you want to do with the year. The 360-degree rotation around the sun, is that more important for you, or whether it's more important on when you are going to get good mangoes next year? Okay, so I will go with the mango definition. Okay, and that is the season. The seasons are governed by this axis coming to the same position after how much amount of time. So that's why this definition is more important for us to consider, because this is the one which governs the seasons. The 360-degree rotation for our practical purposes doesn't mean very much. We really don't care whether the earth has really gone around 360 degrees or even 300 degrees by the time we get the next good mangoes. Okay, so this is the thing. Which one you would care for?
So our measure of year would lead that after the period of precession would get completed, 1 year would be extra, or 1 year would be lost.
I didn't understand that. Can you say that again, please?
So if we define the year like this, from the time when the North Pole and South Pole become equidistant, then after the precession is completes one period, up about 25,000 years. So we will lose 1 year by that time, that 360 degrees one.
Okay, what you are saying is that the number of this 360-degree year, okay, let's call it that, and the number of precisions year, I mean, since the lengths are not the same, by the within the same amount of time there will be different numbers of these different years, and that is true. That is true. That will happen. That does happen even for the definition of a day. Okay, if a day, I mean, I didn't go into the definition of a day, but the day, as I said, it is the time about the one rotation about the axis. How do you determine it? You can determine it by looking at the stars. Okay, or you can determine it by looking at the sun, but those two will not be the same because of the motion of the earth around the sun. Okay, so the definition that we more care for is the definition of going around the sun, because the sun, we get all the energy and so on from the sun, which affect our lives, and the stars do not affect our lives so much.
Dr. Palash, can I just intervene, if you don't mind?
Sure.
I think what our friend was asking, I forgot, I mean, I just missed his name. If we look at, let's say, for example, the Pongal, or let's say within quotes, Uttarayan, that is celebrated in Indian calendar system, it is shifting, right? I mean, a few years ago it was 14th, now it is 15th. If you go and look about 100 years ago in calendars, you will see it as 13th. I have seen it. So this shift means that the date of the so-called Uttarayan will keep shifting, and in this 25,000 years, I mean not 25,000 years, whatever is the cycle for the precision, it will keep moving through the whole year, and then I mean, maybe after a few thousand years, you will see that according to this, Uttarayan is on, I mean, some other part of the year. That's what the kid was trying to mention.
Yeah. Well, thank you for the clarification. Maybe I did not understand this question fully, but if this is what you asked, then this is the perfect answer.
Some other lecture, and I think he was connecting both together.
Okay. Okay. I mean, this is similar to what I said about Eid ul Fitr.
Yeah.
Okay. Eid ul Fitr, it keeps changing by 11 days or so. So after 33 years, it will come back to the same part of the seasonal cycle. Okay. So yes.
Also, I think just one small comment about which I think I will also request your opinion. This idea of some people kind of using some terminologies which indicate that there is the best calendar, the perfect calendar, the most astronomical calendar, or the most right calendar, or I think are all wrong. We judge n number of calendars by some measure. According to that measure, that is good. So, so saying that they had the best calendar, or Y had the best calendar, I think is a false notion. It's like saying that eating idli in the morning is the best, or poha in the morning is the best. I mean, there is no such. I mean, I'm sorry. Just
I am glad that somebody else also goes back to food when when explaining these things. It's not that I only go back to mangoes.
I got to food every time.
But yes, you are right.
Okay. Thank you. Thanks, everyone, particularly Palash Pal. So thank you, Professor Pal, a lot. We will be in touch, and I may bother you once again after some time.
Okay. Okay. Great. Thank you very much from my side. It's a real pleasure. Okay.
Thank you, sir.
Bye.
Nice session. Thank you.
Bye then.